Hi, in today's class we will see about mesh analysis. So, what do you mean by mesh analysis is, it is also known as a mesh current analysis or mesh current method, right. And this is the method which is used for finding a solution for a network or a electric circuit. And this specific method is applicable only for a planar circuit. First we will discuss what do you mean by planar circuit. So, if you see here I have drawn the two diagrams, right. In the diagram 1, if you see, we have drawn the circuit over the plane surface without any crossover, whereas in case of this non-planar network we have drawn the circuit with the crossover point here. So, this is considered to be a non-planar network and this is the planar network. And here with that this mesh analysis is only applicable to a planar network. Planar network is a circuit which does not have any crossover in it, is said to be a planar circuit, and this mesh analysis is applicable only for a planar network, right. And now let us see algorithm or a procedure to find the solution using mesh analysis. So, the first thing is that we have to identify, or we have to say whether your network is a planar or non-planar network. So, that one is the first step in the mesh analysis, and the second step is we have to identify number of meshes in the circuit. We have to identify the number of meshes in the circuit. So, for example, consider this circuit, let this one be V, R1, R2 and R3, right. So, now consider this general circuit. For this circuit we are going to find the mesh current or a branch current using a mesh analysis method. So, for which the first step is we have to identify whether the circuit is a planar or non-planar. So, here there is no crossover point. So, the circuit is a planar circuit. So, we can go for a mesh analysis. So, we have verified the point number 1, and the second step is that identify the number of meshes. In this circuit I have identified 2 meshes. So, first of all we will say what is mean by mesh. So, what do you mean by mesh? Mesh is nothing but a closed path in a circuit is said to be a mesh. So, here if you see, consider this circuit. In this circuit we have one closed path and the second closed path, right. We have a 2 closed path in this circuit. So, we have identified the number of meshes, right. After identifying number of meshes, we have to assign the mesh current, that is your third step. So, here I have assigned the mesh current. Let the current in the mesh 1 be I1 and the current in the mesh 2 be I2, right. So, while assigning the current direction, here we have one constraint which has to be followed is the current direction assigned in the first mesh has to be followed in the second mesh. So, here if you see here, we have assigned the clockwise direction, the same direction has to be followed in the mesh 2, right. So, this is your mesh 1, mesh 2, and I have assigned the mesh current to be I1 and I2 both in the clockwise direction with respect to the source, right. And the next step is apply KVL equation, right. So, for each meshes, so for example, for mesh 1 or a loop 1, we are going to write a KVL equation. As you know, the KVL equation or a KVL says that the algebraic sum of a voltage around the closed loop is equal to 0. So, by applying a KVL in mesh 1, the equation will be minus V plus voltage across resistor 1 plus voltage across resistor 2, which is equal to 0, which can also be written as V is equal to I1 into R1 plus I1 minus I2 into R2, right. So, here if you see here, have written I1 in this case. Here the current this resistor is present only in the mesh 1. So, here we have only possibility of a current I1, whereas your R2, the resistor R2 is common between mesh 1 and 2. So, here we have a possibility of flowing both the current in this mesh, in this resistor. So, here while writing a equation 1, I have to consider your I1 to be positive, your I2 to be negative. So, for writing a current across or current flowing through a resistor R2, your current equation will be I1 minus I2 into R2. So, from which your V is equal to I1 into R1 plus R2 and minus I2 into R2. Let this one be your first equation, and when you write a KVL equation to your loop 2 or a mesh 2, your equation will be R2 into I2 minus I1 plus R3 into I2 equal to 0, right. As I said before, this current this resistor R2 is common between mesh 1 and 2. So, we have both the current I2 and I1. Since we are writing an equation for a mesh 2, we have to give a preference for your current I2. So, that is why here I am writing it as I2 minus I1 plus the current flowing through resistor R3 will be I2. So, it is I3 into R3 into I2 is equal to 0. So, this can be simplified as minus R2 into I1 plus I2 into minus I2 of R1 plus R3 is equal to 0. So, let this one be your second equation. By solving equation 1 and 2, you will be getting a solution for I1 and I2. Alright. So, this is how we are going to find the solution for a current, voltage or a power across a circuit or across a branches using this mesh analysis. So, once again I repeat, this mesh analysis is nothing but it is also known as a mesh current method, and it is applicable only for a planar circuit. And the procedure to find the solution using a mesh analysis is that first we have to identify whether the circuit is a planar circuit or not. And the second step is that we have to identify number of meshes in the circuit. After identifying the number of meshes, we have to assign the mesh current in the circuit. After assigning the mesh current, apply a KVL equation to the each loop individually. By that we will be getting a simultaneous equation. By solving the simultaneous equation, you will be getting the mesh current. After getting the mesh current, we can find the branch current, branch voltage or a power across a circuit. So, this is how we have to find the current or any other parameter using a mesh analysis method. So, in this case we will solve some problem in this. Right. So, consider this simple circuit and this simple problem. In this case, the question is find the mesh current. Here the circuit is given. So, we have 42 volt, 6 ohms, 3 ohms, 4 ohms resistor, and we have 10 volt voltage source. Right now, we will see how to find the solution for this problem using a mesh analysis method. So, as I said, the first thing is that we have to check whether the circuit is a planar or not. So, the condition is satisfied, given circuit is a planar circuit. So, we can go for a mesh analysis method. And the second step is that identify the number of meshes. As you look into the circuit, we can see we have a 2 loop or a 2 closed path in a circuit. So, we have a 2 meshes, and now we are going to assign the mesh current, which is your third step. So, I1 and I2 after assigning the mesh current, and while assigning the mesh current, please make sure that the current direction in the both the meshes should be same, right. If it is not mentioned in the question, while assigning the current direction in the both the meshes should be same. And the next step is we are going to apply a KVL equation to each meshes. So, by applying KVL equation in loop 1, you will be getting minus 42 plus 6 into I1 plus 3 into I1 minus I2 equal to 0, right. So, once again I repeat, by KVL equation as we know, it is nothing but a algebraic sum of voltages around the closed loop is equal to 0. So, here we have a voltage source, and so we are considering it to be a voltage drop. So, it is minus 42, it is minus 42, and next is we have a 6 ohms resistor. We have only the current I1 flows into this 6 ohms resistor. So, it is plus 6 into I1 plus 3 into, if you take this resistor 3 ohms, this resistor is common between mesh 1 and 2, right. So, while writing a current for this particular resistor, it should be I1 minus I2 equal to 0. Since we are writing a loop 1 KVL equation, this current I1 is considered to be positive, whereas your I2 is negative, right. So, equation once again I repeat, the equation will be minus 42 plus 6 into I1 plus 3 into I1 minus I2 is equal to 0, right. And similarly for your loop 2, let us start with 3 ohms resistor. It is 3 into I2 minus I1. Since we are writing an equation for a mesh 2, your current I2 is positive here, whereas a current I1 is negative, right. And next is plus 4 into I2 minus 10 is equal to 0, right. Now, we have to simplify this both the equation. So, from which you will be getting 9 into I1 minus 3 into I2 is equal to 42, and here it is minus 3 into I1 plus 7 into I2 equal to 10. Now, we have to solve this two simultaneous equation. So, by a substitution method, or you can use a calculator also. So, by finding the solution for this, you will be getting I1 as 6 amps and I2 as 4 amps. Right. So, this is how we have to solve the problem using mesh analysis method. Now, we will go for a second problem. Right. So, this is your second problem. The question is determine the power supplied by a 2 volt voltage source in the given figure, right. So, the question is finding the power supplied by this 2 volt voltage source. So, for the given circuit, if you see, we have to check the algorithm. According to an algorithm, the first step is we have to check whether the circuit is a planar or non-planar. So, if you see here, there is no crossover point. So, your circuit is considered to be a planar circuit from which we can make sure that your mesh analysis is applicable to this circuit. And the second step is we have to identify the number of meshes in the given circuit. So, if you see here, we have a 2 closed path in the circuit. So, we have a 2 meshes. Let us mark this 2 meshes as L1 and L2. After identifying the number of meshes, and the third step is to assigning the mesh current. So, here I am assigning this current to be I1 and the current in the mesh 2 be I2, and as I said before, both the current direction should be same in both the meshes, right. Here I have assigned the current in the clockwise direction, and after which the next step of a mesh analysis is we have to apply the KVL equation. Now, by applying a KVL equation, it is minus 5 plus 4 into I1 plus 2 into I1 minus I2 minus 2 is equal to 0. So, by simplifying this, you will be getting 6 I1 minus 2 I2 and it is equal to 7. Let this one be your equation 1, and after which we can apply a KVL to your loop 2. It is 2 volt plus 2 into I2 minus I1 plus 5 into I2 plus 1 is equal to 0. Alright. So, once again let me explain this KVL equation. While writing a KVL equation for a loop 1, it is a current entering the negative of your supply. So, it is minus 5 plus 4 into I1 plus 2 into, since this resistor is common between both the meshes, it is 2 into I1 minus I2, and here we have one more voltage source. So, here the current is entering minus, so it is minus 2 is equal to 0. After which I am simplifying your equation, from which you will be getting 6 I1 minus 2 I2, and when we add this together it is minus 7, and when it goes to a left hand side it is equal to 7. So, let this one be your equation 1, and now when you apply a KVL equation to your mesh 2, here the current is entering a positive of your supply or a battery. So, it is plus 2 plus 2 into plus 2 into, since we are writing an equation for your mesh 2, the current I2 will be considered as a positive. So, it is I2 minus I1 plus 5 into I2, and again here we have one more voltage source where the current enters into the positive terminal of your battery. So, it is plus 1 is equal to 0. Right. Now, again you simplify this equation, it is minus 2 I1 and 2 plus 5 7 I2 equal to minus 3. Let this one be your second equation. Right. This is how we are getting a 2 equation. Next, by solving this 2 equation, you will be getting current I1 as and by solving this simultaneous equation, you will be getting I1 as 1.131 ampere and I2 as minus 0.105 ampere. So, after finding this mesh current, we have to find the current that is